We have gazed into the abyss of time, seeking to understand the universe's birth. The Big Bang, a cosmic symphony of light and energy, birthing galaxies, stars, and planets. But what of the final act of this cosmic drama? What fate awaits the universe as the curtain falls? Today we embark on a journey to the edge of time, exploring the forces that could ultimately unravel the very fabric of existence. Join me as we explore three potential destinies that could spell the end of the universe as we know it. In the grand cosmic ballet of gravity, the universe is currently expanding, a relic of the Big Bang's explosive birth. But what if this expansion, this outward rush of galaxies, is not eternal? What if gravity, the architect of stars and galaxies, eventually halts this expansion and reverses its course? The Big Crunch hypothesis paints a picture of a universe where gravity reigns supreme. Over eons, the expansion slows, eventually coming to a standstill. Like a ball thrown skyward that loses its momentum, the galaxies, under the relentless pull of their collective gravity, begin to fall back towards each other. At first, this cosmic fall is slow, almost imperceptible, but as eons pass, it accelerates, gaining momentum. Galaxies, once separated by vast distances, draw closer, their mutual gravitational attraction increasing exponentially. Star systems within these galaxies begin to feel the pull, their cosmic dance accelerating, their orbits tightening. As the universe contracts, a cosmic traffic jam of unimaginable proportions ensues. Galaxies, now crammed into ever-shrinking space, collide in a dazzling but deadly display of celestial fireworks. Stars, once distant suns, now blaze across the sky, their light a searing reminder of the universe's impending doom. The temperature of the universe, once cold and dark, begins to rise, fueled by the relentless energy of colliding stars and galaxies. The cosmic background radiation, a faint echo of the Big Bang, intensifies, bathing the cosmos in an inferno of heat. Black holes, those cosmic predators lurking at the heart of galaxies, feast on the chaos, growing larger and more voracious with each passing moment. Their event horizons, points of no return, expand, threatening to consume everything in their path. As the universe shrinks, the very fabric of space-time contorts and twists, a cosmic tapestry unraveling under the immense pressure. The laws of physics, once reliable constants, begin to break down, their equations no longer able to describe the unfolding chaos. Finally, all of existence, all the matter and energy that once spanned billions of light years, compresses into an infinitesimally small point, a singularity. This singularity, a point of infinite density and temperature, marks not just the end of the universe but the end of space and time itself. The Big Crunch, the ultimate cosmic collapse, a mirror image of the Big Bang, erasing everything that ever was, leaving nothing but an echo in the void. The universe is expanding, pushing galaxies further apart, stretching the very fabric of space-time. But what if this expansion continues indefinitely, inexorably driven by the echo of the Big Bang? What if, instead of a cataclysmic crunch, the universe faces a slow, chilling death? This is the chilling prospect of the Big Freeze, also known as the heat death of the universe. In this scenario, the universe continues its expansion, a slow, relentless stretching that has profound consequences for the cosmos. As the universe expands, it cools. The cosmic microwave background radiation, that faint afterglow of the Big Bang, gets stretched and diluted, its energy dissipated across the ever-growing void. Stars, those cosmic furnaces that light up the universe, slowly fade away. Their nuclear fuel, hydrogen, is consumed, transformed into heavier elements, until finally they can sustain their fusion fires no longer. Giant stars explode as supernovae, briefly illuminating the cosmos. But even their light eventually fades, leaving behind only remnants, neutron stars and black holes. As stars die out, fewer and fewer new stars are born. The raw materials for star formation, clouds of hydrogen and helium gas, become increasingly scarce, spread thin across the vast expanse of space. Galaxies, once vibrant islands of star birth and death, gradually fade into darkness, their spiral arms dimming, their starlight extinguished. The universe, once ablaze with the light of billions of galaxies, grows darker, colder, and emptier. The temperature of the universe, which has been steadily dropping since the Big Bang, continues its descent towards absolute zero, the point at which all molecular motion ceases. In this frigid, desolate future, black holes rule. No longer fueled by the remnants of stars and gas, they slowly evaporate through Hawking radiation, a faint trickle of particles leaking from their event horizons. But even black holes are not immune to the relentless march of time. Over unimaginable eons they too disappear, their immense mass dissolving into a whimper of radiation. The universe, once teeming with stars, galaxies, and the potential for life, becomes a cold, dark, and utterly desolate place. Space, once punctuated by the light of countless stars, becomes an endless empty void. Time, once marked by the cycles of stellar evolution, loses all meaning in a universe where nothing ever changes. The Big Freeze is not a cataclysmic end, but a slow, inexorable decline into darkness and cold. It is the ultimate fate of a universe destined to expand forever, where entropy reigns supreme, and the potential for life and complexity is extinguished in the face of an ever-expanding void. Chapter 3. Big Rip, the universe torn asunder. The universe is expanding, driven by a mysterious force we call dark energy. But what if this expansion is accelerating, pushing galaxies apart at an ever-increasing rate? This is the terrifying prospect of the Big Rip, where the very fabric of the universe is torn apart by dark energy. It drives an accelerating expansion, increasing exponentially over time. The gravitational pull between galaxies weakens, unable to overcome the accelerating expansion. Galaxies begin to unravel, their stars flung out into the void. Planets are ripped away from their stars, cast adrift into the expanding void. This is the moment of the Big Rip. Microscopic tears rapidly expand, ripping through galaxies, stars, and even atoms. The Big Rip is a violent, catastrophic end to the universe, a cosmic undoing of unimaginable scale. Chapter 4. Quantum Collapse. The Universe Vanishes. The universe, as we understand it, operates according to the laws of physics, a set of rules that govern everything from the smallest subatomic particles to the largest cosmic structures. But what if these laws, these seemingly immutable foundations of reality, are not as fixed as we believe? What if the universe exists in a precarious state, susceptible to sudden, unpredictable shifts in the very fabric of existence? This is the unnerving possibility presented by the concept of a quantum collapse of the universe. To understand this idea, we must delve into the strange and counterintuitive world of quantum mechanics, the realm of the very small, where the rules of classical physics break down. In the quantum world, particles like electrons and photons exist in a state of superposition, meaning they can be in multiple states at once until observed or measured. This inherent uncertainty is not just a quirk of quantum systems, it is woven into the very fabric of spacetime itself. Quantum fluctuations, tiny ripples in the fabric of spacetime, constantly arise and disappear, even in the vacuum of space. These fluctuations are usually harmless, but there's a theoretical possibility, however improbable, that a sufficiently large fluctuation could occur, with catastrophic consequences for the universe as a whole. Imagine, if you will, a quantum fluctuation of unprecedented scale, a sudden dramatic shift in the energy state of the universe. This fluctuation could create a bubble of true vacuum, a region where the laws of physics are fundamentally different from our own. This bubble of true vacuum, driven by an inherent instability, would expand at the speed of light, engulfing everything in its path. Within this bubble, the constants of nature, the fundamental values that govern the behavior of matter and energy, would be rewritten. The masses of particles, the strengths of forces, even the number of dimensions could be altered, transforming the very nature of reality itself. As this bubble of altered reality expands, it would collide with the universe as we know it, with catastrophic consequences. The boundary between the true vacuum and our universe would be a wall of unimaginable energy, annihilating everything in its path. Stars, galaxies, even the fabric of space-time itself would be consumed, leaving nothing but the altered reality in its wake. The quantum collapse of the universe is a chilling prospect, a sudden and unpredictable end to everything we know. It is a reminder that our understanding of the universe is far from complete, and that the laws of physics as we understand them may not be the final word. Outro. The universe is a vast and mysterious place, full of wonders and terrors beyond our comprehension. The Big Crunch, the Big Freeze, the Big Rip, the quantum collapse, these are just a few of the possible endings that scientists have envisioned for our universe. Each scenario, a chilling reminder of the universe's impermanence, of the delicate balance of forces that sustain our existence. The ultimate fate of the universe remains one of the greatest unsolved mysteries in science. Will it end in fire or ice? Will it be torn apart or collapse upon itself? These are not merely academic questions but inquiries that strike at the very heart of our existence.